I'm going to move fairly swiftly through this set of examples since the video embedded in the page offered more detail. And since this is a practice problem, you should have completed it on your own first and then come to watch this. So my answer should just be confirmation and not news. If you haven't tried it on your own, grab a copy of the periodic table, pause this video, and give it a go. The biggest trick with our first example is remembering that the symbol for potassium is K. Once you know that, you can get the rest of this pretty easily. Here you can see I've given you both of the isotopic symbols. Know that the atomic number is not always included because it is technically redundant. If we know we have potassium, then we know we have an atomic number of 19. The mass number was given in the name, and so that is 37. Remember, that is the sum of the protons and the neutrons. The atomic number and the number of protons will always be the same value. That's 19 in the case of potassium. I know I do not have an ion here because the word cation or ion is not included. So that means I have an atom, and that means that my protons and my electrons must be equal so that I have the same number of positive and negative charges and thus come out neutral. I find the neutrons by subtracting the atomic number from the mass number, and in the case of this specific isotope, that gives me 18. Oxygen is familiar to most people, so this might be the easiest one on there. Here we have oxygen 17. I know that because the mass number is given up and to the left of this element symbol. The atomic number for oxygen is 8, and I find that on the periodic table. It will be the whole number value in the elements periodic table entry. My mass number is 17. My atomic number is the number of protons, so that means I must have 8 protons. Again, I do not have the word cation or anion or ion anywhere, and I have no charge written in, so that I must have the same number of electrons as I do protons. I find the neutrons, again, by subtracting the atomic number from the mass number, and that's going to be 9 for this isotope of oxygen. We haven't done one before where we have to work backwards, so to speak. Here, you're given the atomic number instead of the name or the symbol, which is no big deal because we know the atomic number defines our element. We also know the table is arranged in order of increasing atomic number, which makes things easier to find. Once I remember all of that, I can figure out that I have boron, specifically boron 11. This has an atomic number of 5 and a mass number of 11, and I can use those two pieces to figure out the protons, neutrons, and electrons. There are 5 protons because that corresponds to the atomic number. There are 6 neutrons here because I can take the atomic number and subtract it from that mass number. 11 minus 5 will give me 6. I have a neutral species, so I must have the same number of protons as I do electrons. Our last one is an ion, so right away we should know that the number of protons will not equal the number of electrons. We're not told whether we have a cation or an anion here, so we'll have to locate the element on the table first to see what kind of ion it would be expected to make. Nitrogen is found up and to the right of the stairstep, making it a nonmetal. Our nonmetal elements will form anions with a characteristic charge. That charge is 3- for nitrogen's column, as gaining 3 electrons would give nitrogen the same number of electrons as the noble gas neon. That charge is important because to correctly write the symbol, I do have to include the charge on the ion. Otherwise, the subatomic particle count I come up with won't match the symbol that I am given. The atomic number will still just be pulled from the periodic table, and that's going to be 7 for any atom of nitrogen or any ion of nitrogen. The mass number here is 15, again given in the name. There are 7 protons in every nuclei associated with nitrogen. There are 8 neutrons in this particular case because 15 minus 7, or the mass number minus the atomic number here, would give me 8. And there are 10 electrons because in a neutral atom of nitrogen, I would have 7 electrons. But nitrogen gains 3, so it can move 3 over to its noble gas. 7 plus 3 will give me 10 electrons.